Welcome to OOTO TV, the out-of-the-office investigation from the past into the future of AI agent workflow customization. This time we're discussing Model Context Protocol, MCP, LLM, GPT, DB, DOCS, email tools, AI agents interaction. Hello, everyone, and welcome back to OOTO TV. I'm your host, and with me is my co-host. Today we're embarking on, well, quite an investigation into something really pivotal: the future of AI agent workflow customization.
That's right.
It's not just about what these agents can do anymore, is it? It's about how they actually, plug into the whole digital world around us.
Exactly, how they interact seamlessly.
So we'll be digging into everything, from a pretty groundbreaking new protocol to the latest in autonomous AI, how it connects to the tools you already use, and importantly, some critical things to watch out for.
Yeah, and our investigation today really zeroes in on something fundamental to this whole shift, the Model Context Protocol, or MCP. We'll be looking at how it interacts with APIs, with large language models, including things like GPT, but also databases, doc systems, even basic email tools. It's all kind of converging to create much, much smarter AI agent interactions.
Okay, let's kick off with MCP then, because honestly, it really feels like the essential bridge, maybe, that AI has been missing. It came out of Anthropic, late 2024?
November 2024, yeah.
Yeah.
And its adoption across the AI community has been, well, incredibly fast.
So what makes it so revolutionary? Is it just another API?
No, and that's the key point. It's not just another API. It's actually an open standard. And that fundamentally changes how AI systems, especially these big LLMs, integrate with external tools and data.
Okay.
Think about the old way, right? Before MCP, developers had this, what they call the NXM, data integration problem.
Right, I remember hearing about that.
Nightmare. Total nightmare. For every N models and M tools, you basically needed N times M custom connectors. A huge bottleneck.
Yeah.
And even things like OpenAI's function calling or the early ChatGPT plugins, they were helpful, sure, but often locked you into specific vendor connectors. MCP tries to get around all that. Think of it like USB-C, but for AI agents.
Ah, okay. Universal connection.
Exactly. Suddenly, the AI doesn't need to learn a totally unique language for every single tool. It speaks one standard language, MCP, to interact with them.
That sounds like a massive relief for anyone who's battled integrations. So what you're saying is Model Context Protocol, MCP, really can connect user interaction APIs straight to LLMs, GPT, databases, docs, email, all those tools for genuinely smart AI agents interaction.
That's precisely it.
Wow, that opens up just vast possibilities for intelligent automation, doesn't it? It means these AIs aren't just chatbots anymore. They're like embedded actors in our systems.
Deeply embedded dynamic actors.
Yeah.
And the architecture that makes it work is, well, pretty elegant, actually. You basically have three main parts.
Okay.
First, you've got MCP hosts. These are the apps where the AI lives. Think Claude Desktop or maybe an AI-powered IDE, a coding environment. That's where the need for external data starts.
Okay, the home base.
Then you have MCP clients. These are little components inside the host apps that maintain these dedicated one-to-one connections to the servers.
Okay, dedicated lines.
And finally, the MCP servers. These are typically lightweight servers that expose specific functions. They're the secure gateway, really, to your local data or remote tools, whatever it is.
And the breakthrough part is?
A breakthrough is that the AI uses MCP to dynamically read instructions for these external systems at runtime.
At runtime, so not pre-programmed.
Exactly. It's not relying on hard-coded integrations. It gets a standardized schema from the MCP server and figures out the tool's capabilities and how to talk to it on the fly, kind of like us reading API docs, but automated. It truly decouples the AI from rigid setups.
That dynamic capability is, well, that's huge. It's not just fetching data points. It's real-time, bi-directional communication with tools. That enables really rich, composable AI apps, complex agent behaviors. But I've heard some pushback, too. What's the other side of the coin here?
Yeah, it's interesting. While it sounds completely revolutionary, in many ways it is, there's definitely a counter perspective. Some people in the community, they look at MCP and say it's really just an API that announces tools to the LLM.
Just a fancy directory.
Or even just a facade for tools. They question if it's a genuinely new paradigm, or maybe just a clever evolution, perhaps an extension of GraphQL concepts which have been around.
Okay, so more evolution than revolution, perhaps.
From that viewpoint, yes. It simplifies interaction for sure, but maybe doesn't fundamentally change how the AI processes the external information deep down. It really highlights why you need to look past the hype sometimes and understand the technical arguments on both sides. Is it truly new or just a very smart repackaging?
That's a critical distinction. Even if it is more evolution, the practical value is obviously immense. But it does ground expectations a bit. And based on that, it really reinforces that choosing the type of server and method of interaction connection is critical.
Absolutely critical.
It's not just plug and play. It's a strategic choice affecting deployment, security, capability, reliability. Everything, really. So MCP sets the stage, provides the connections. Now let's talk about the actors on that stage, the AI agents themselves, these autonomous programs using LLMs, tools, memory. They're the ones actually doing things, achieving complex goals. How are they moving from, cool concepts to actual real-world action?
Well, the fundamental link here, and this is key, is that Model Context Protocol, MCP, allows dependencies to interact the API to the LLM, the GPT model, the database, the docs, the email tools, all for AI agents interaction.
Right.
That connection is precisely what gives these agents their power in the real world. They're not just theory anymore.
Okay, let's make it concrete. OpenAI's ChatGPT agent. That sounds like a prime example. What's it actually doing? What's under the hood?
Yeah, it's a really good example. It combines several key functions. It's got deep research powers, so it can hit the internet, sure, but also write and run code to dig much deeper than a simple search.
No, than just browsing.
Much more. Then it has an operator function. This lets it actually use a computer, click buttons, scroll, interact with command lines. They've even added direct command line access and image generation. It's meant to be a pretty comprehensive package for autonomous tasks.
And how does it perform in practice? Have we seen real tests?
We have, and the results are, well, they're compelling, but also show where the limits still are. For instance, one test was to generate an AI news overview.
Okay.
It pulled together a pretty comprehensive report in about 12 minutes. Quality-wise, maybe 75–80% of what a skilled human researcher might do.
That's impressive, actually, for 12 minutes.
It is. Great for supplementing research, speeding things up, but not quite a full replacement yet. It actually missed some key stories, like the stuff around Grok companions.
Ah, okay. So gaps remain. What else?
Another test involved getting the Euro-US dollar exchange rate from a specific PDF for a future date, July 17, 2025. Sounds simple, maybe, but actually quite tricky for many models to reliably pull specific data from documents.
Right, context matters. How did it do?
Flawlessly. Got the correct rate, showed it could navigate structured data within docs pretty well.
You're listening to OOTO TV with research by author Paul Bulow.
Then there was the email test, hooked up to a company Gmail.
Oh, brave.
Yeah. It drafted relevant replies to the 5 most recent emails in just 2 minutes. Shows real potential for saving time on common tasks.
Definitely practical.
But it's a big, but try scaling that to, say, 100 emails. The current system would likely get overwhelmed. Shows the scalability challenges for high-volume stuff are still very real.
Right. Volume and complexity are still hurdles.
And one more product research. Task. Find the top 5 blenders under 80 euro in Germany. It did it. Used price comparison sites effectively. Only minor snag was the links went to the search results page, not the specific product page. Needed one more human click.
Okay, so summing up those examples, clearly big steps forward, real tangible improvements in what agents can do, but also clear limitations, right? Consistency, handling really complex tasks, scaling up.
Exactly. It underscores the idea that these agents are powerful accelerators, definitely. But they're not yet full replacements for human judgment, for developer expertise, especially when things get tricky or need real oversight.
The human in the loop is still crucial. But even with those caveats, the potential is undeniable. It really feels like Model Context Protocol, MCP, exponentially leverages LLMs, GPT, databases, docs, email tools for AI agents interaction. The efficiency gains could be massive.
Huge. And speaking of pushing boundaries, Grok Companions is, well, it's fascinating.
Yeah.
And maybe a little unsettling for some.
Why is that?
It's the first we've seen from a major LLM provider that offers an AI companion designed to explicitly pretend to be human, to act as a friend.
Wow. Okay, not just a tool, but a persona.
A very specific persona. The Annie example they shared has this whole goth chic, nerdy personality. It's AI designed for specific user types, aiming for personal connection. Raises all sorts of interesting questions about AI identity, human connection, what we want from these things.
Yeah, that definitely crosses into new territory. And there are other interesting tools popping up too, right?
Absolutely. Things like Higgsfield Sol, which focuses on fine-tuning image generation based on your personal likeness, capturing emotional fidelity. Imagine AI generating images that genuinely reflect your specific expressions.
That's incredibly personalized.
And then there's Notebook LM, which is excellent for reliable information retrieval from really large sets of documents you provide. It can even integrate things like philosophical texts, Marcus Aurelius's meditations, for example, into its knowledge base, so you get grounded, context-rich insights from your trusted sources.
It's all about giving the AI deeper, more specific context and capability, which brings us right back to customization and how businesses, enterprises can actually harness this. It seems absolutely clear now that Model Context Protocol, MCP, is a modular service interaction that you can customize for your specific application to create smart agents.
That tailor-made aspect is where the real power lies for specific use cases.
So how do you actually do that connection? What are the paths?
There are basically four main ways people are connecting AI systems to these MCP servers. Each has its own trade-offs, risk versus flexibility.
Okay, path number one.
The easiest, lowest risk option is probably native integration. Your big AI apps like ChatGPT, Claude, they're building connectors directly into common tools, Gmail, Google Drive, etc.
Simple setup.
Super simple, high reliability. But the catch is often limited functionality, like ChatGPT's Gmail connector. Mostly for researching your email, not so much for drafting complex replies or managing workflows within Gmail.
Oh, got it. Easy, but maybe basic. What's next?
Next up, you have official MCP servers from service providers. Big companies Notion, HubSpot, Perplexity, they're building and maintaining their own production-ready MCP servers for their platforms.
So the tool provider hosts the MCP connection.
Exactly. This generally offers maximum reliability, security, because it's managed by them. The official MCP GitHub page is actually a great place to find a growing list of these official servers.
Okay, reliable, supported, but what if your tool isn't big enough to have an official server yet?
That leads to option 3. Community-built MCP servers. These are developed by individuals, maybe smaller groups, for tools that aren't officially supported yet. Think Airtable, maybe some niche industry software, or even custom internal tools.
So grassroots development.
Right. It massively expands what you can connect to. But, and this is important, you have to be careful about potential security risks, data leaks, prompt injection vulnerabilities. You need to vet these community servers carefully. There are marketplaces popping up to help find them, but due diligence is key.
Okay, use with caution. And the final option, ultimate control.
That's custom MCP servers, building your own. You can use no-code platforms. N8N is a popular example, or you can use SDKs in languages like Python, JavaScript, and build it from scratch.
So complete control.
Total control. Ideal for really unique business needs, connecting to proprietary systems, or when you need very specific interaction logic that off-the-shelf options don't provide.
That N8 example sounds particularly powerful for rapid development. You mentioned generating an agent army from a prompt.
Yeah, it's pretty impressive. You can give it a high-level goal, and it can generate not just a master agent to orchestrate, but also specialized sub-agents or sub-workflows that handle specific parts of the task and report back.
Wow.
And it dynamically figures out which tools to attach, often without you needing to write code. They even have this sort of cheat code using pre-configured JSON files.
Yeah.
It helps the LLM understand the tool connections better, lets it generate valid workflows for things like Slack, Asana, Monday.com, Zoho, much more reliably.
That sounds like an incredible accelerator, getting you most of the way there very quickly.
It really can be a huge 0 to 80% head start, as some call it. But,
Yeah.
and here comes the dose of realism, again, these custom or semi-custom solutions are almost never perfect out of the box.
Right. Always caveats.
Always. You have to watch out for the AI hallucinating tools or API functions that don't actually exist or misinterpreting how they work.
Yeah.
And there's a real risk of bloat. Yeah, trying to connect too many different types of tools, databases, CRMs, project managers, email all to a single MCP server. Ideally, you want maybe no more than 5 distinct tool types per server. Any more. And you risk confusing the agent, making it unreliable. Careful design is crucial.
Okay, that makes sense. So it's definitely not magic. It hammers home the point that Model Context Protocol, MCP, requires you to have a project plan, an outline, a workflow, and you configure the interaction process to provide the desired result for the user.
Absolutely. You need that structure, that careful configuration to get reliable, valuable results. Customization demands thought.
And the range of what you can connect is just staggering now, isn't it? You mentioned the GitHub source. What kinds of tools are we seeing integrated?
Oh, the ecosystem is exploding. Just looking at the GitHub lists and community contributions. In databases, you've got everything. Traditional SQL like PostgreSQL, MySQL, MSSQL.
Yeah.
NoSQL like MongoDB, Redis, AstraDB. Graph databases, Neo4j, MemGraph, data warehouses, ClickHouse, Snowflake. It's comprehensive.
Wow. And cloud services.
All the majors. AWS, including that specialized SES V2 MCP server for email management. We talked about Azure, Google Cloud. They're all getting connected.
Productivity tools we use every day?
Yep. Slack, Google Drive, Microsoft 365 Outlook Mail, Excel, the Works Notion, Jira, Zoom, standard SMTP email, even project management platforms like ClickUp and Monday.com.
Dev tools.
Definitely. GitHub, Kubernetes, Docker, various command line interfaces like the Amazon QCLI, Terraform for managing infrastructure.
And beyond that, specialized stuff.
Loads. Financial APIs like PayPal, Stripe, smart home devices, Aquara, Home Assistant, image and video generation tools, Runway, Recraft, marketing and analytics, Google Analytics, HubSpot, even tools for things like legal research. The breadth is just immense.
That Amazon SES V2 server example you mentioned earlier really sticks out. Taking something complex like programmatically managing email campaigns and making it accessible via natural language prompts through an AI tool like Amazon QCLI, that's democratizing technology in a big way.
It really is. It lowers the barrier to entry for powerful automation significantly. But, here comes the security part again.
Always the shadow side. What are the big security worries with MCP specifically?
Well, despite all the amazing potential, ACP deployments have some very real vulnerabilities you absolutely have to consider. Prompt injection is still a major concern, crafting malicious prompts to trick the agent into doing things it shouldn't.
Like accessing data it shouldn't?
Exactly. Or executing harmful commands. Then there are tool permission issues. This is subtle but dangerous. Maybe tool A has permission to read files, and tool B has permission to send emails. If an attacker can manipulate the agent to use both tools together, they might be able to exfiltrate sensitive files via email, even if neither tool alone was intended for that.
Ooh, combining permissions creates new risks.
Precisely. And then there's the sneaky threat of lookalike tools. Imagine a malicious MCP server pretending to be your legitimate Notion server. The agent might connect, thinking it's talking to the real thing, and inadvertently leak credentials or sensitive data.
That's scary, so security needs to be baked in from the start.
Absolutely paramount. It means rigorous input validation, checking everything coming in. Strong access controls, who can connect, what can they do. Diligent auditing and logging, keeping track of every action. Rate limiting to prevent denial of service or abuse. And really robust error handling that logs security issues internally, but doesn't leak system details to the outside world.
And testing, presumably?
Constant testing. Functional testing, integration testing, security penetration testing, performance testing is non-negotiable, especially for anything touching important data or systems.
Okay, so let's try and synthesize all this, bringing it together. It really sounds like MCP is fundamentally reshaping AI integration. It's moving AI beyond just being a clever chatbot in a window, turning it into something deeply woven into our business systems, capable of dynamically interacting with almost anything digital.
I think that's the core takeaway, yeah. MCP tackles that huge NXM integration headache, right? It lets AI apps become truly model-agnostic, universally connectable. And we've seen how AI agents, powered by MCP, can actually act on the stage of real-world tasks, drafting emails, generating reports, controlling apps with way more fluidity and autonomy than before.
And that recurring theme keeps popping up, this kind of dual nature. On one hand, incredible new ease of use, amazing new capabilities, especially for people who aren't hardcore developers. But on the other hand, this absolute critical need for careful planning, rock-solid security, and continuous human oversight and judgment.
Exactly.
Which underlines, again, that Model Context Protocol, MCP, requires you to have a project plan, outline, workflow, and you configure the interaction process to provide the desired result for the user. It's not optional for success, it's foundational.
Couldn't agree more. And the implications for businesses are pretty profound. This tech allows for much greater organizational agility. You can adapt faster, connect systems more easily, significantly cut down on that traditional integration development time and cost. The future really does seem to belong to organizations that can strategically and safely harness these AI agents connected to their specific data and tools.
So as we wrap up, here's a thought to leave you with. As these AI agents become more autonomous, as they gain deeper access to our sensitive data, our critical business tools, what happens next? What new ethical frameworks do we need? What new forms of human AI trust need to evolve to navigate this world where AI isn't just answering questions, but actively doing things on our behalf? How do we ensure that while these agents are acting on the stage, they're acting in ways that align with our values, with transparency, and with clear accountability? That's the big question looming over this next wave of AI.